What's up, you data friends? It's Yanis here and welcome to my channel. This video is video part 1 of the machine learning decision trees series of videos where we're going to show how to run decision trees, random forest, and extreme gradient boost machine learning models in Python. And just to show you a quick overview of what we are going to cover, first we're going to go through the libraries we need, then we're going to go through the machine learning process, then I'm going to show you how to load raw data from SQL or from Excel CSV into Python, and then we are going to go through the data pre-processing phase. After this one, I'm going to show you how to run decision trees and the different ways of evaluating decision trees. Then we're going to go through how to run random forest models and how to tune their hyperparameters in order to improve our results, which is what we do over here. And then we're going to do the same for the extreme gradient boosting models, so how to run it and how to tune its hyperparameters. After we finish with our models, we're going to pretend that it's a business scenario where we get some new raw data, unseen raw data, and we want to make predictions on that raw data, which is what we are going to do. We are going to predict whether it's a customer churn or not, and what's the probability of that customer becoming a churn or not. And at the end, I'm going to show you how to export our model predictions and deploy them in a Power BI dashboard that looks like this. And I'm going to show you how to build this from scratch, where the business can see how many new customers they have from that new unseen raw data, what are the potential churns, so the number of people who we are estimated are going to churn, the variables affecting the people who are going to churn, and then a customer details table where the business can see all the people and their details that are going to churn. So we can see this person over here, for example, we are predicting it that is going to churn with a probability of 74%. So they can come in this dashboard, they can filter all the people that we predict that are going to churn, and then work on these people so we can retain them and not lose them. And before we start this tutorial, let me just say that if you're new to my channel and you're passionate about data science, then please consider liking this video, subscribing to my channel, and enabling notifications for my future videos. Right, the first thing we need to do is to load the packages we need. So for this tutorial, I'm using operating system, NumPy, Pandas, Matplotlib, and Seaborn, which is our main ones, and then a few libraries from sklearn. So make sure you have all these libraries. You can actually copy them and paste them from my GitHub repository. And if you're missing any of these libraries, then all you have to do is just pip install the library. So for example, I can copy and paste this and run this just to show you. And this is telling me that the requirement is already satisfied because I have already installed this library. Moving on, we have the machine learning process, which is the process we are going to follow for this tutorial. So we're going to start with the problem formulation. We're going to load our raw data. Then we're going to do some data pre-processing, split our raw data, run our model, then evaluate our model, then apply some hyperparameter tuning, and then repeat this process until we are happy with our final model. Right, going to problem formulation now. So what are we trying to solve? Imagine that we work in a bank and our manager has asked us, data scientists, to predict if a customer is going to churn or not, with the overall aim of identifying those customers early and trying to stop them from churning. So retaining as much customers as possible and as much business as possible. Right, next we need to load our raw data, and I have two ways of loading the same raw data. The first one is from SQL Server. So if you have an SQL Server, you can input the data there and then load it into Python, or you can just download the CSV file I'm going to have in my GitHub repository, and then you can load it by calling the pd.readcsv. And then into pd.readcsv, all you have to do is paste the path of the file. So let's say my path is this one over here. I can just click on it. I can copy it. I can come over here. I can paste it. At the end, I need to specify the name of the file and then .csv, and then use this encoding as ladin-1. Then I just print the shape of my raw data, which is 10,000 rows, as you can see, so observations, and 14 columns, and then I just display the first 5 rows. So in our raw data, as you can see, we have the row number, the customer ID, the surname, then the credit score, geography, gender, age, tenure, balance, number of products, has credit card, is active member, the estimated salary, and then whether it's a churn or not. Right, moving on, we have the data pre-processing phase, and what I'm doing in this code is that I investigate all the elements within each feature. And when I say feature, I mean column. And the way to do this is that I say for column in raw data, so this is gonna create a loop for each column. I create this unique values list, which is going to have the unique elements within the column. So for example, it's going to start with row number, and this is going to have, because we have 10,000 rows, it's going to have 10,000 unique values. And then I calculate the length of those unique values. So because we know it's 10,000 rows for row number, this is actually going to be 10,000 too. So both of them are going to be 10,000. And then what this is saying is that if the NR underscore value, so if this number is less than 36, then it's going to print the number of values for feature, and then the feature is going to be this column over here, so row number. So this is the result, the number of values for feature row number. Then it prints the number of values, so 10,000 as we've said, comma, the unique values over here. But because the NR underscore values is more than 36, it's going to print the second bit. So it's only going to print the column and then the NR underscore values. So for example, if we go down to geography, that the unique values is only going to be 3 unique values, which is France, Germany, and Spain, is actually going to print those unique values. So this is basically a very quick code to see the number of features within each variable and also the distinct values of those features. So for example, in geography, we only have 3 distinct values, which is France, Germany, and Spain. In gender, we only have 2 distinct values, which is male and female. In tenure, we have 11, and we can actually see them. Then number of products, we have 4. Has credit card is 2, etc., etc. So if I change this 36 now to 10, for example, you will see that tenure, because it's 11 and is more than 10, is not going to print the unique values. So let's test it. So if I do 10 and then run it, you can see in tenure now, we don't have the distinct values. So I'm going to leave it as 12 for now, so we can see tenure too. Right, next I want to check if we have any null values. So I call my data frame .isNull.sum to sum all the null values per column. However, as you can see, no column has any null values, so I can move on into visualizations. So the first thing I always do is to run a pair plot from SNS, which is Seaborn library. So what I do is that I limit the raw data to only include the numeric columns. So from here, as you can see, we are missing geography and gender because they are not numeric. And I also exclude the row number and the customer ID because they are basically, we don't need them right now in our visualizations. And in order to create the pair plot, all you have to do is say sns.pairplot. Then you feed your data frame, which is this data frame over here, which only has numeric values. I set my hue equals exited. So I want the distinction to be whether it's a churn or not, because this is what we are going to predict later on. And then this diag underscore KWS is just to limit my pair plot so I don't get any errors. And just to investigate our pair plots now to see if there is any relationship that is going to help later on when we are predicting, we can see that credit score with age, where we can actually see it over here, there is a very good relationship, as in people who are less than 20 or more than 60 are more likely to not churn, and then people in between are the people who churn, just because orange is the churn and then blue is the people who are not churning. So again, if we check other graphs, we can see there are good relationships over here, which is tenure and age. There is good relationships over here again, which is age and number of products. And then for everything else, I think there is not much of a relationship. Right, moving on, I want to investigate my non-numeric features because we've done numeric upon here. So now I'm going to create bar plots for geography, gender, and I have also included age, tenure, number of products, has credit card, and is active member, just because they have a lot less unique values, so I can visualize them in a bar plot. And what I do over here, I say for feature in features over here, then I want to plot a figure, and this figure is going to be my sns.count plot, x equals f, which is my feature. Then my data is going to be our data frame, so the data frame we created above. And then my hue is going to be whether it's a churn or not. And then I set my palette into set 1. And now just to investigate it, from geography, we don't get much over here. From gender, again, I cannot get much info from it. Then from age now, this is where I get some information, is that we can see for people who churn have more of a normal distribution. And then people who don't churn, so the red is more of a right skew distribution. So that's good to know. Then for tenure, again, not much. Maybe I need to turn them into percentages to understand this better. Same for number of products, actually, we get a very good information from this graph, because we can see that people with 3 or 4 number of products are almost always churns. So it's always blue, apart from this small red into 3. And then from has credit card, again, I need to turn them into percentages, but there is not much, I think. Same for is active member. Again, there is not much information from this graph. Right, the next thing we want to do now is to make our categorical variables into numeric representation. And the reason we want to do this is because the model, so the mathematical equation later on, is not going to understand a character. So Germany or France, for example, we need to give it a number so it's going to understand it. So we need to turn Germany or France into a number, so 0 or 1. And the way to do this is the following. We call our new data frame now new row data, and then we want to say pd.getDummies. We want to feed it the previous data frame, so the one we actually have. So if I visualize this one for you quickly, so you see it. And then we need to select the columns from this data frame we want to turn into numeric representation. So I've selected geography, which is this one over here, gender, which is this one over here, then has credit card, which is this one over here. As you can see, these two are actually numbers, but because the difference now is implying something, 0, 1, 2, 3, it's not actually the way we want to represent it. We actually want to separate it in 2 different columns, so the difference doesn't imply anything. So for example, with number of products, because the difference matters if you have 1, 2, or 3, or 4, so if it increases, it matters, then we need to leave it as it is. But for has credit card and is active member, it's a yes or no answer. So we need to turn it into a categorical representation. So as you can see down here, after I run it, for the geography, now this column is gone from here and it created 3 extra columns. So geography France, geography Germany, and geography Spain. And because the first row now is actually geography France, under France we have 1, and under Germany and Spain we have 0. And it's the same case for has credit card. So if I go under here, has credit card, you can see 0 and 1. And now the 1 has moved under the 1 in the column heading. And the same case for is active member. Right, moving on, the next step we have is to scale our data. And we want to do this for 2 things. The first one is because it makes our machine learning models run faster. And the second one is that it can improve our model's accuracy because we normalize the distribution of our inputs. Sometimes though, it's not always the case. Right, the first thing I do is that I select the variables I want to scale, and this is going to be the credit score, the estimated salary, the balance, and the age. and then I call my scaler, which is the min max scaler, and then I feed my scaler into those columns. So I say new raw data and then scale variables, so these variables equals scaler.feed transformation, and the transformation is going to be applied in those variables, and the transformation is going to be the min max scaler. So what this means, how it works, is that for balance, for example, is going to take the minimum value and then the maximum value. Let's calculate it quickly. So if we select the column balance, which is this one, and then we do dot min, you can see that the minimum value is 0. We can also check the maximum value, which is this 250,000. Is going to select 0 to 250,000 as our 0 and our 1, and it's going to force all the numbers in between into a number between 0 and 1. So as you can see, for the first one, which is 0, it stayed with 0. But for the second one, which is 83,000, it converted this number into 0.33. And the same thing applies for all columns that we have scaled by selecting the minimum value, the maximum value, and then converting those into numbers between 0 and 1. Right, moving on, we have to split our raw data into X and Y so we can feed it into our model. So what I'm doing here is that I'm saying X equals new raw data, which is this data frame above here, but I actually want to drop my Y variable, which is the exited, which is this one over here. And then I want to select the values, and then my Y is only going to be exited, and then I want to say dot values. Then I print my shapes just to make sure they are correct. So as we can see, we have 10,000 observations and 15 variables to feed in our model as X. And then as Y, we only have 10,000 observations and then one variable, which is 0 or 1. Then I also split my raw data into X-train, X-test, Y-train, and Y-test because I'm going to use the hold-out validation technique. So I'm going to use 90% of my data to train the model and then 10% of my data to test the model, just because I want to test our model on unseen data, so data that the model has never seen before. And then because I'm going to know the answers, which is my Y test, I can compare them and select the best model. Right, the next step now is to run our decision tree model. And some notes before we do that is that decision trees are supervised machine learning methods that are used for both classification and regression. So you can use them to predict both classes and continuous numbers. And the way it works is that you really have to understand how information gain or entropy is calculated and how it works. So I suggest watching these two videos first just to understand information gain and entropy before you move on with this tutorial. But I'm going to try my best to explain it in a very simple way. So the algorithm begins with the original set S as the root node. So what this means is that it goes through every single column or attribute or variable that we have, and it calculates the information gain or the entropy, and it chooses the one with the highest information gain or the lowest entropy. So H is the variable with the highest information gain. And then on each iteration of the algorithm, it iterates through every unused attribute. So it goes through every unused variable and it calculates again the entropy or information gain of that attribute. Then it selects the attribute which has the smallest entropy or largest information gain. So it repeats the same process now for the variables left. So our next variable is the number of products and the isActive member as the ones with the highest information gains. And then after we select these two, we produce more subsets of data, which is this point over here. And then the algorithm continues to recurse on each subset, considering only attributes that never selected before. So it's going to go through every single attribute and it's going to create this tree, this decision tree based on the entropy or information gain, and based on how much depth you want your decision tree to go. Because here I have stopped it only on 2 iterations, because if you run on all iterations, then you're going to have overfitting issues that we are going to discuss later on. Anyway, this is a very simple way of explaining how it works, and just to translate it into numbers, what this is saying is that if the age of the customer is less than this 0.318, by the way, this is scale data. So just to understand it better, I think we can run it on not scale data. So if I go up here, run this one and remove the age from the scaling. So we're going to make it more understandable. Now age is the actual age. And then we rerun our decision tree. We can see that what this is saying is that if the age of the customer from our raw data is less than 41.8, then it's going to move down to this tree over here. Otherwise, it's going to move down to these 3. Actually, there are branches, I think, this branch over here. And then we're going to continue with other variables now with if and else until we reach out whether it's going to be a customer churn or whether it's going to be a retained customer. But because I have only set the max depth to 2 now, what this is going to do is going to start with the first observation. So the first customer has age of 42. It's going to come over here and it's going to say, if the customer is less than 41.5, our customer is not, then we're going to go over here. If then is active member is less than 0.5, so if I go to is active member 1, which is the, where is it? Is active member 1 is actually 1. So it's actually more than 0.5. We're going to move down to this branch. And this is saying that we predict this as a churn. Let's check if he's a churn or she. They are actually a churn. So we can actually see the one over here. So we've done the prediction correctly. Right. And just to explain how to run the code now, if I quickly go back and add the age back in the scaling, because we've removed it from here, and then we rerun everything else so we can work with the scale data. So I say dt equals decision tree classifier, so just call it, I set the criterion into entropy. So if you follow this link here, you can read all about this classifier from sklearn, and I want my criterion to be entropy because the default one is Guinea. I also set the max depth equals 2. So this is the number of iterations you're going to have. So I only want to stop in the second one. So if you read about max depth is the depth of the tree. And if you leave it as default, then it's going to run until all variables from your xtrain are going to be used. And the last thing I do is that I set my random state equals 1. And this is because in case I want to replicate my results, it controls the randomness of the estimator. Then I say dt.feed and I feed it on my x train and y train. So if I run this again, and the next thing I do before I evaluate my model is just I want to visualize the tree, which is running this bit down here. And in order to visualize the tree, we are going to use this library over here, and we're going to say tree.export the graphic visualization. Into brackets, I'm going to give it my model, which is this model over here. Ignore this. Then my feature names, I want them to come from the data frame before we split it into X and Y. And I want to drop the exited and I want to use just the columns. And then for the class names, I want to do the same as above, but I only want to use exited and then the unique values as string values. Then I want it to be filled, I want it to be rounded, I want to have special characters. And in order to visualize it, I need to call this dot underscore data into my graphic visualization dot source. And then you will be able to visualize the model you've created above here. Another thing I want to show you before we evaluate our model is how to calculate the feature importance. So remember how I told you the decision tree works based on feature importance or entropy, and it chooses the variables with the highest feature importance. We can actually calculate it. And what the output of this means is that we can say to the business that the most important variables that are affecting your customers' churn are the following, and then you can give them the ones with the highest feature importance. In order to calculate it now, what I've done over here, you can actually copy and paste this code. I said for I, column in enumerate, and then I set all my variables apart from my y variable. So I drop my exited. Then I want to print the feature importance of the column that I start. So I'm going to go through every column. And in order to get the feature importance, all you have to do is say dt.feature_importances underscore, and then I, which is going to be my first variable. So you can see here, it prints the feature importances of all variables. And the bit in the middle is that I create a data frame where I say variable, and then I use the column, and then feature importance, I use the feature importance of the first variable. And then I save these, the first time this is going to run, this first bit is going to fail because final underscore fi is not existing, so this is going to fail, and we're going to move on into this bit of code down here. So it's going to pass the first data frame into final def, and the second time it's going to run, it's just going to merge the previous feature importance with the new feature importance. So as we go on, we create this data frame and we insert new lines, which is the new column with the new feature importance in the data frame. And the last bit I have over here is that I just order the data from my data frame based on feature importance score, and then I want them to appear as ascending. So this means the highest is going to be the first. So this is the output of the query above here. So when I call my data frame, this is the data frame I get. So I can see the first variable is age with the highest feature importance. So this is why we start with age above here. The second variable is number of products, and this is why we have number of products down here. The third is active member underscore one, and we have it over here, etc., etc. Right, the next thing we want to do now is to evaluate our model. And to do this, I'm going to call the score on the training dataset and the score on the testing dataset. So as you can see, we've predicted 82% correct when we evaluated our model on the same dataset that it was trained on. And we have also performed 82% accuracy when we evaluate our model on data that has never seen before. So this is actually very good to have 82% accuracy. However, accuracy is not the most important, or maybe is not the only evaluation metric you should check. The next one I'm going to show you is the confusion matrix, which is very important to see when you're predicting classes to evaluate. So in order to create it, first you're going to have to run this function, which is the confusion matrix function. So it creates the confusion matrix. I have actually found this on the internet a couple of years ago, so you can just copy and paste this one as it is. Then to plot it, the first thing we have to do is to predict our y. So let me just show you what this y predict does. So this is going to predict, what did I do? So run and then paste it. So this is going to make predictions on our X train. So if it's a customer churn or not. Then we need to calculate the confusion matrix numbers in order to fit them into this plot. So if I run this quickly to show you what this does, this is giving us the confusion matrix numbers. So this is how many people we've calculated correctly that they are not churns. This is how many people we've calculated correctly that are churns. And then these two numbers are the people that we have misclassified, this one as churns and this one's as not churns. The next step I have over here is that we need to normalize the data. So we need to turn them into percentages. And then to plot the figure, we have to call this function above here, which is this one. We have to fit the normalized data that we have just calculated, which is this one over here. We need to pass the classes, and we can get the classes from the model we have just run, dt.classes underscore. and the title is going to be the training confusion matrix. So what this is telling us now is that we can predict very well the people who are not churns, so a 91% accuracy on the zeros, but on the ones we only have 46% accuracy, which is telling us a very different story from this 82% accuracy we have above here. Because yes, we get the zeros accurately, but the aim of the business, or our aim, is to predict the churns as accurately as possible in order to help the business. A quick way to try to improve our results now is to increase the max depth of our model above here. So we can have 3, 4, or 5 iterations. So just to show you how this is going to look like, if I make this 3 now, and if I run our decision tree visual to view it again, you can see now that we have another breakdown after the number of products, which is using again number of products and then balance. So I think the reason it's using again number of products is because it ran out of variables that have information gain. So if I run this again, we can see that now we have balance giving some information gain, but after balance, there is 0 added value from the rest of the variables. So I think this is why we repeat the same variables into our decision tree model. But anyway, if we run the accuracy now over here, we can see that it improved. We have higher accuracy. And then if we run the confusion matrix again, we can see that it dropped a lot when it comes to 1. And this is because we are overfitting the data. So you need to be careful with the max depth of your trees, because you are overfitting the data and then you are not going to have good results. Right, if we go back and change it quickly back to 2, so we are not overfitting again, and rerun it. So 2, then we run this one, then we run this one, then we run our score, then our confusion metrics, back to the 46%. Some additional metrics now to evaluate how good your model is the sensitivity or hit rate or recall or true positive. All these things are the same under one metric. Another one is the precision or positive predicted value. These two have different names, but again, they are the same thing. The next one is the false positive rate or false alarm rate. The next one is the false negative rate or miss rate. And the last one is the classification error. If you want a deep explanation of how these work and how they are calculated, I mean, I have the code over here, but I have explained them very well in this video over here when we are running logistic regression. You can go and watch it just to understand how they are calculated and when to use which metric, but I'm not going to go into it right now. The next thing I would normally do after running decision trees is to try to tune their hyperparameters in order to improve our results. But I'm not going to do this now because I'm going to show you how to do this when we run the random forest trees down here. However, because this tutorial is long as it is, I'm going to stop this tutorial here and finish the rest of it in the next video. Right, so I hope you've enjoyed this tutorial and you've gained enough value out of this tutorial. And if you feel like you did, please click that like button, subscribe to my channel, and enable notifications for my future videos. If you have any questions, please let me know in the comments below. Otherwise, thank you very much for watching this video, and I'm going to see you in the next video.